Hi, we are Team 25 and our topic for the project is training LLMs to self-correct via reinforcement learning. So, LLMs have shown remarkable abilities in reasoning tasks like math and coding. However, they often lack the capability to effectively revise or self-correct their initial responses, especially without external feedback. So, this is referred to as intrinsic self correction, and it hinders the development of LLMs that can implement more complex reasoning strategies and improve their outputs autonomously. Existing approaches for training self correction either require multiple models or rely on various forms of supervision. Our task is the reimplementation of the multi turn online reinforcement learning approach known as SCORE. This was introduced in a research paper by Google DeepMind in September 2024. We use the base models Llama 3.2 1B and Llama 3.1 8B with chain of thought and self-refine with iterative feedback as the baselines. We evaluate these models on a subset of problems from the math dataset, which contains diverse mathematical problems across various difficulty levels and topics. So let me explain our implementation for SCORE. It is a multi-turn approach where a single LLM is trained to not just generate responses but also critique and refine its own outputs. What's unique here is that this self-correction happens without external supervision during inference. So the process starts with an input question which is passed to both our model and a small reference model. The reference model generates logits that act as baseline, helping to stabilize training. By comparing the logits of a model with the reference model using KL divergence, we ensure that the model explores improvements without deviating too far from the baseline behavior. The real novelty of SCORE lies in its two-pass design. So, after the first pass, the model combines its initial output with a self-correcting prompt, essentially rethinking its response. The second pass produces a refined output, which is then evaluated using a reward function. So in stage 1, we balance the reward for better responses with KL divergence from the reference model, giving more weightage to the stability by setting a higher value for beta. In stage 2, we focus on maximizing rewards across both passes, with beta 1 ensuring the iterative improvements are prioritized. It also uses a reward bonus term that encourages improving responses from the first attempt to the second. This careful weighting ensures a smooth transition from stability to self correction as the model learns. So, in our work, we uniquely combine guidance from a smaller reference model, multi turn refinement, and a carefully designed objective function to train LLMs to self correct. This overcomes challenges such as distribution shift and behavior collapse, enabling a robust and scalable framework for autonomous self improvement.
Okay, coming to results, this is Kaushik. So, uh, we did 600 steps, training steps of stage 1 and 600 training steps of stage 2. You can see we get a lot of initial rewards in stage 2 versus stage 1, but it kind of stays the same for after the reward that we get after the self-correction prompt. Now, uh, before we did score, this was our accuracy, and but after score, we see that our accuracy went up, but what happens is our self-correction went down. So basically, to conclude, what we can conclude that like our stage 1 is not working correctly. We need to probably improve the magnitude of the parameters. The thing is, stage 1 is supposed to restrict the model from making any much improvement in the first accuracy, so that the second accuracy can improve. Uh, okay, coming to the real world impact, we can say that if we improve small algorithms in self-correction, it will help in like improving agents made from small algorithms. These agents are basically like LLMs in loops.